going to show you concerning pH and pOH calculations is sometimes it's not going to give you the H plus concentration immediately or the OH minus concentration. Sometimes it's going to tell you the concentration of an acid or a base, and you're going to have to figure out the pH from there. So I'm going to show you a couple examples of that. Now, usually it is not that hard. We can get tricky sometimes, especially if you start using some weak acids or bases, but you're not going to see that a whole lot, at least in this class. Okay, so we have here the concentration of this acid, HCl, is 0.054 molar. HCl, hydrochloric acid, is a strong acid. What does that mean? It means that it completely dissociates in water to become, now we'll do the official hydronium solution, to become H3O plus plus Cl minus. Okay, do you see here then? Let's look at the mole to mole ratio. For every 1 mole of this, we have 1 mole of this. So because of that, if this is the concentration of HCl, because concentration is moles per liter, so if we have 0.054 moles of this, well, let's say we have a liter of it, we're going to have 0.054 moles of this. So typically, on this, you can see that this is also the concentration of H+. So what you need to do, look, is this a strong acid? It is. I'm going to give you strong acid examples. Honors, you're going to have a couple weak acid examples, but I feel like you can handle it. But for the most part, I'm going to give you strong acids. That will be the concentration of H+. So the concentration of H+, or H3O+, equals 0.054 molar. So at this point, to find the pH, we do the negative log of that concentration. I'll go ahead and get that answer for you. Please practice doing it yourself as well. Negative log 0.054. We have 1.2 two sig figs, honors, 2 sig figs. So it'd be 1.3. There's your answer. Okay? Now let's look at this next one. Do we see that we have NaOH here? This is a base. So NaOH is a strong base. In solution, it turns into Na plus and OH minus. So that means that this is our concentration of NaOH, but it is also our concentration of OH minus. So the concentration of OH minus equals 0.178 molar. So in order to find the pH, we're going to first have to find the pOH equals the negative log of 0.178. That's going to be our pOH. How do I know that? Look at that OH right there. If it's a base, it's going to be our concentration of OH minus. If it's an acid, it's going to be our concentration of H plus. So let's put that in our calculators. We get negative log of 0.178. That is our pOH, 0.7, we have 3 sig figs here, 750 mole, nope, that is definitely our pOH there. In order to find our pH, we've got to subtract that from 14, which is going to give us 13.250. So there you have it. There you have it. Okay. Now, this last one is really just for my honors folks. My academic folks, you won't be seeing any problems like this, but I wanted to show this to you just so that honors can see this. When we break this apart, now I'm going to do the simpler version without the hydronium. I'm just going to do the H+. When we split that up, remember what happens to the 2? The 2 goes to the front. 2H plus SO4, 2 minus. So if our concentration of H2SO4 is 0.033, do you see for every 1 mole of this, we have 2 moles of this? There's twice as many H pluses as there are H2SO4s. So that means that this concentration is not going to be the same. We actually have to multiply that concentration. And there you go. So that's what we plug into the pH formula. Negative log of 0.066. And that's going to be our pH there. Negative log of 0.066. And we get just 2 sig figs, 1.2. And there you have it. That's everything you need to know about calculating with pH, pOH, H plus concentration, OH minus concentration. Looks much harder than it is. You guys got this.